All right, it's recording now. We're going to begin with the questions of the questionnaire. And the first one is, oof, how many right triangles have a hypotenuse that measures 4x plus 5? Triangles? Hypotenuse? What is that? I don't remember that. Then, the same triangle has legs that measure 3x plus 13 and x inches. How many triangles? And also, find the dimensions of those triangles. Oh, this exercise is good. This is a good exercise. All right, let's take a look at the question. So we're talking about triangles, right? And since we're talking about triangles, the first thing that we mathematicians like to do is draw them, right? Show a representation of the exercise. In this case, I am going to just do one right triangle. So let's do this line and then another line like this, okay? And then a hypotenuse, something like this. There we go. This will be the right angle. So here I have an example of a right triangle. And now if we were to complete the diagram, we need to write down the measurements. Now, we don't know for sure the measurements of this triangle. We don't know them. But we know that in the example, in the exercise, we know that the hypotenuse measures exactly 4x plus 5. So let me write it here. The hypotenuse would be this one, right? The largest side, or the opposite to the right angle, right, would be 4x plus 5. There we go. That is the measure of our hypotenuse. Continuing with the diagram, we also know that the legs measure 3x plus 13 and x. But what are the legs in a triangle? Okay, the legs are the other sides, right? Bianca just wrote a 2, so that means Bianca is done with the quizzes. Thank you, Bianca. Beautiful. All right. So we can choose and we can put whatever. We can say that this is 3x plus 13 and this other leg will be x. Or we can just say this is the leg that measures x and this is the leg that measures 3x plus 13. It doesn't really matter, to be honest. I'm going to choose the longest to be x, because why not? And I'm going to choose the smallest to be 3x plus 13. 3x plus 13. Now, if at the end of the exercise, we find that this x is, I don't know, 10, then this leg will be 30 plus 13, so 43, right? If I say that x is 10, this will be 30 plus 13. So this side will be longer than this one, right? If that happens, it's okay. That means the diagram is not correct. But the diagram is there only to help us visualize the exercise. This is not to scale, all right? The position of the numbers doesn't really matter as of now, all right? So let's continue with the exercise. How many triangles have a hypotenuse that measures 4x plus 5, legs that measure 3x plus 13, and x inches? Ooh. So, okay, so we have our diagram. Now, how do we find how many triangles? What do we do from here? Well, we're going to have to put on our thinking hats for this exercise because, as you can see, it's not easy. And the exercise is not giving us really any clues about this. It's not really giving us any tips or clues. But we do know one thing. We do know from our geometry that any right triangle like this one, right? Any right triangle just like this one has a beautiful property in mathematics, a beautiful theorem that if you like mathematics or you hate mathematics, you dream about the theorem. Does anybody know what theorem am I talking about? In the chat, please. If you have an idea, write it right now. Okay, Mr. Alba and Mrs. Campo. Yes, you guys are correct. Valerie, you're correct. Sophie, you're missing the square, but you are correct. Pythagoras or Pythagorean theorem. Beautiful. We can apply the Pythagorean theorem to this triangle because the triangle is a right triangle. So we know from every triangle, we know, we're going to write it right here. We know that the hypotenuse, we know A, B, and C, right? We know that the hypotenuse square is the addition of the square of the other two legs. So A and B are going to be my legs. This will be my leg A. This will be my leg B. And this will be my hypotenuse, C. So from Pythagoras, we know that the two legs squared, if we add them, that addition will give us the hypotenuse squared as well. And with this, since we're talking about squares, with this, we can do some replacements and find out what happens next. We can do that. We can do that. All right, let me read the chat right now. Some people are writing things. Pythagoras, Pythagorean. Jose says, Richie says que la hypotenuse es el lado más largo. Okay, kinda. Y se puede usar Pythagoras. Yes, Richie, you can use Pythagoras. You can use Pythagoras, Richie. Yes. So by doing this, by using this, we can know things. Maybe using this didn't help us at all. Maybe that is what happens with these exercises. Since we don't have a procedure like question A, B, C, first do this, then do this, we don't really know what to do. So we are going to have to explore. We're going to have to come up with ideas, and maybe those ideas work. Maybe those ideas don't work. We are only going to know if we apply these ideas, if we test these ideas. So let's test this one. This is my idea. I feel like this maybe could be useful. We're going to test this and see if it works. And if it doesn't, we're going to come up with a different idea. All right? So let's replace our values of A, B, and C, A, B, and C, and see what happens. All right. Replacing the values, I have that A is 3x plus 13. This will be the value of A, and the Pythagoras theorem says that the value of A should be squared. Right? Then plus. Now let's replace the value of B. And for us, the value of B is x. So we have an x squared. B squared means x squared. Right? Continuing with this, I have our value of C, which is 4x plus 5. So let me write it right here. 4x plus 5. And this value is squared as well, because we know that the hypotenuse will be squared. So doing this, we replace the values. And look at that. Now we have an equation. An equation involving the variable x. We have an x over here, an x over here, and also an x over here. So what do we do with this? Okay, to be honest, I have no idea. But I sure can tell you that we have a parenthesis here with a power, and we also have a parenthesis here with a power. Why don't we solve the power? Why don't we solve the parentheses? We can do that and see what happens next. Maybe that helps us. All right, let's do that. Okay, in case you don't know or you forgot, you don't just apply the root, the exponent like this. You don't do that, all right? That will be a mistake. You can only do that if the operation inside the parenthesis is a multiplication or a division. But here, the operation inside the parenthesis is an addition, a plus. When you have this, you cannot apply the square like this. You're going to have to use something you guys learned in 8th grade. A plus B square is going to be the first term square plus 2 times A plus B plus the last term square. A square plus 2AB plus B square. Okay? Let me do something here because I don't think you guys can see it. Okay. There we go. Better. A little bit better. Just a little bit better. There we go. Okay? We are going to have to use this formula. We are going to have to use that formula to expand our binomial here. Somebody's asking something in the chat. Let me see. Sara Jimenez says, Profe, one question about the classwork. Yes, tell me.
Profe, can I say it in Spanish or is it necessary in English?
Please say it in English.
Okay. Is that Maria Paz Penagos sent you a mail asking if the easy homeworks count as classwork or like stamps for the class?
Yes.
So there is a problem because some of the students doesn't know that, so they're not counting that. So
Okay.
what is the deal?
Choose. What would you say? Do we accept those exercises then, or do we don't?
No.
Somebody said no.
I don't know, but the problem is that the ones that already sent it to me has to resend it. So I don't know.
So let's do something, all right? Some people send them, and those people are counting with those exercises. And the people who didn't send them either didn't do it or didn't count those exercises. Okay, so let's just count the exercises that the people is sending. All right, if they send you with that counting in mind, cool. If they didn't send that counting in mind, okay, cool as well.
But that is not going to affect the grade of others because the ones that count the easy activities is going to have more stamps.
Yes.
So, but like what I'm saying is that the ones that already sent it to me didn't know that they had to count the easy activities.
What easy activities are we talking about? The stamps? For the easiest activities,
no,
we gave you stamps.
The ones that they have, I don't know. I really don't know. It's like she asked and she counts some, but the easy activities has a stamp. So I really don't know. I'm really confused about that.
All right, look. If you're counting an exercise as a stamp, then it counts as a stamp. You cannot double count it. You cannot, oh look, I have a stamp for this exercise, but it's also an exercise, so let's count it twice. No, that doesn't work. The exercise is either a stamp or an exercise, right? So if the people are counting the stamps, the easy activity, as stamps, they already counted as stamps. You cannot count it again as exercises. All right? Is that better?
No, it's not clear.
Vamos a decirlo en español, ¿listo? A ver.
Sí.
Resulta que los ejercicios que hicimos en el colegio, los de Easy Activities, ¿cierto?
No, porque los hicieron en la casa.
Exacto, esos son en la casa, o bueno, como sea. Pero esos ejercicios ¿cuáles hice entonces? No. Estoy perdido por las hice.
Yo también, según yo son... Espérate, ya te pregunto cuáles son los que contó y ya te digo cómo funcionan.
Creo que los de elimination y substitution.
Ok, mira, este es mi punto, mira, aquí voy, este es mi punto. Easy Activities, hasta este momento, durante la virtualidad, no hemos tenido Easy Activities.
No.
O sea que si hablamos de Easy Activities, tiene que ser las que hicimos en el colegio, ¿cierto?
Sí.
Y bueno, y si las hicimos en el colegio, pues entonces pusimos sellito por ellas, porque eran en el colegio, ¿verdad?
Sí.
Bueno, entonces cualquier ejercicio de Easy Activity cuenta es como los sellitos que yo puse o los que pusieron las monitoras. Pero...
entonces si no tiene sello no cuenta.
Si no tiene sello, pues no, porque lo hizo después o alguna otra cosa.
Pues sí, porque pues normalmente lo que se hacía con la ICE era que iba para lo del quiz. O sea, una de las ICE fue para el quiz y la otra... No sé qué pasó con otra, pero sí.
Perfecto.
Creo que también fue para el club. Entonces, sí, listo. Gracias. Entonces, o sea, los que ya lo mandaron, déjenlo así. Muchas gracias.
Muy bien, Sara.
Vale.
All right, let's continue. I have no idea where I was. Nico Parra says, so we use special products? Yes, sir. We're going to use this special product. We're going to use that special product. And we're going to amplify our expression here. We're going to expand it, all right? By expanding it, we're going to have some things. Let's see what we do. All right. In case you forgot, the A represents the first term in our binomial. A will be, in this case, 3x. So every time in our expansion, every time we have a value of A, this A and this A, every time we have a value of A, we are going to replace it by the first value in our binomial. Remember, the binomial is separated by the addition, the sign in the middle. So we have two terms. 3x is the first term, will be our A. And we have a second term, 13, which is the second term, B. Okay? So let's expand our project here, our product. So we know that by expanding this, we need to write the A, the first term, square. So the first term is 3x. 3x squared will be 9x squared. 3x squared. So 3 squared, 9, and x squared, x squared. Right? Let's continue. We have an addition here. That's what it says. Whenever we have an addition, we have an addition here. And then we need to multiply 2 times the first term, also multiplied by the second. Okay, so we need to multiply 2 times the first term, 3x, also multiplied by the second term. There we go. This will be 2 times A times B. 2 times A times B. 2 times A times B. Okay, cool. And last but not least, we have our last term squared, B squared. So the last term will be 13. That means we have 13 squared. Of course, 13 squared is something we can solve, and we will solve it. But we're going to solve it in a minute, not right now. Let's continue with the exercise, because right now we just expand this whole part. This will be the whole expansion that we have over here. But we are missing also the x squared, and we also need to expand this part over here, right? So this exercise is looking to be pretty interesting now. All right, let's continue writing. We have the first expansion, then plus x squared, and then all of these equal to the second expansion. Has anybody done the second expansion? Please, in the chat, everybody, I want everybody to please expand this second part just like I did with the first one, and write it in the chat. Let's see who does it first. Wait, drop the mic. What happened with Parrado, brother? What happened with Carlos? You guys are good. What's going on? There are a lot of people who are really, really good at math. All right, let's see. Have 2 people answering. And these people looks like they are correct. Okay. Sara Galvis and Sara Jimenez. All right. Richie, man. Yes, sir. Yes, sir. Pretty good, Richie. Pretty good. Okay. Do we have somebody else? We have 3 people now. Do we have somebody else? I'm going to write this expansion and I'm going to explain it in a minute, but I want to see who else has the answer. So far, we have 3 winners. Does anybody else have an answer? María Paz. Okay. Parado. Perdón, profe, se me fue el Wi-Fi. It's okay, buddy. It's okay. You don't see mine, María José Fonegra. Oh, look at there. Yes, you were the first one, actually. Majo Fonegra. Yes, congratulations. Majo Fonegra was the first one. Beautiful, Majo. Ethan, you are correct. Oriana, you are correct. Danny, you are missing 1 term. 1 term, but you are correct. But you are missing 1 term. We're going to see it in a minute, all right? Marino. Yes, sir. Perfect, Marino. Perfect. All right, my turn now. Let's go. Let's go. So in order to expand this second part, we have to again apply the same little formula over here, the special product that we have, okay? So the first thing is the first element squared. And we know the first element is 4x. So we're going to have to elevate 4x to the second power. Elevating this means the solution will be 4 to the 2 and then x to the 2. So 16x squared. Most people have it correct. Beautiful. Let's continue. We have an addition here, and since we have an addition, we also need to write an addition over here. Plus 2 times the first term times the second. Let's write it down. 2 times the first term, which is 4x, times the second, which is 5, right? So here was the mistake that some of you did. And I need to say it. I need to write it. I need to show it to you. So 2 times 4x, then times 5. So Danny Osorio, you wrote 15. I'm thinking the little 1 that you put over here in front of the 5, that's just a typo because the rest is correct, okay? But it is a 5 because the second term is 5. So not 15, all right? Cool. Let's continue. And last but not least, the second term, the b, also squared. The second term will be 5, so we have 5 squared. All right. We expanded the whole question, and now this thing is really big. Can we contract it a little? Yes, we can. We can do this multiplication and also do this one over here and find out the results. All right, let's write it down over here. The first part will be 9x squared. This part is easy. I am not doing anything to the first 9x squared. I'm just carrying it down. But the second part is something we can multiply. We are going to have to multiply the numbers and then leave the x alone because we cannot multiply the letters, right? There are no more letters to multiply. So we have 2 times 3 times 13. You can do this by using a calculator or just using your calculation abilities. All right? This 2 times 13 will be 26. And then 26 by 3 will be 26 by 3. So 18, right? In case you cannot do it, 26 by 3. You do this in a corner in the notebook. That is allowed, so you can do this. 3 times 6, that is 18. You're going to carry a 1. Did you guys remember this way of multiplying? Huh? You used to multiply like this in, I don't know, 6th grade? Huh? Well, we use it every single time, right? Even the teacher uses this. So don't be ashamed. Just do it. And then 2 times 3, that's 6, plus the 1 we carry, that is 7. So this will be 78x. Don't forget about the x. Continuing with this, we have our 13 squared. But that 13 squared, how much is that? Well, if you don't know, you're going to have to do the multiplication. 13 by 13. I know it is 169. But in case you don't know, in case you don't remember how to multiply like this, let's do it. 3 by 3 is 9. And then 3 by 1 is 3. Then you're going to carry one, move a little space to the left. 1 times 3 is 3. And 1 times 1 is 1. Add these 2. 9 with nothing is 9. 3 and 3 is 6. And then 1 with nothing is 1. So 169. Did you guys remember that way of multiplying? Also, in case you can use a calculator, we'll just put this in the calculator. You're going to save a lot of time, right? Let's continue. Then plus x squared equals, I'm doing this one, I'm doing the equal as well. And then continue with this part over here. We have 16x squared. And this multiplication, well, how much is that? All right. 2 times 4 is 8. And how much is 8 times 5? Well, that thing will be 40. That will be the 40 that everybody brought in the chat. Congratulations, guys. You were right. And then 5 squared, which is 25. Beautiful. We compacted a little bit more. Okay. But what now? Why are we doing this? Can you guys remember? Why are we doing this thing like this? Well, I don't remember. Whenever this happens, guys, whenever something like this, like you don't remember why are you doing something like this, or what is it that you have to do next, you just go ahead and read the question again and see what happens. All right, the question was, how many right triangles have a hypotenuse? Oh, look at this, right? We are talking about a triangle that have some measurements. We have a hypotenuse, a leg, and another leg. And then we come up with the idea of applying the Pythagoras theorem, right? All we did was replace the values and then expand the exponents. Okay, cool. I remember now. All right, that is what you should be doing in case this happens to you. All right. From here, you know what we have? We have an equation. That is the idea of an equality. We have an equation. And the letter, the variable that we have is x. Can we solve this equation? Can we solve for x? Looks like we can. We have a tool. Remember the tool that we used the last class? The quadratic formula? That quadratic formula, you can use it when you work with questions like this, with quadratic equations. Okay, but what do we need in order to apply the quadratic formula? Okay, I'll tell you. We need an equation like this. Let me erase the first part and write it here on the top. We need an equation in this form, ax squared plus bx plus c, and the equation has to be equal to 0. If we have this, then we can apply the formula. But our equation is not like that. We need it to be equal to 0, and this thing is not even equal to 0. Look at this. We have, in our equation, we have one term elevated to the x squared. I'm sorry, one term which has an exponent of 2, ax squared. One term. And we have 1, 2, and 3 terms. We also need just one term that is with the coefficient x. One term, x. And we have 1 and 2 terms. Also, the constant c has to be just one constant, and we have one constant and another one here. So what do? How do we transform these into these? We're going to have to use algebra, guys. We are going to have to use algebra. So the first thing we want to do is reorganize all of these and make it so that in one side of the equation is the variable 0, and in the other side of the equation is the entire equation. And we can do that by just moving the things on this side all the way to the right. Right? We can also move all the things in the right. We can move this to the right. And we will have the 0 here. But if we do that, look, the 16, when we move it to the left, the moment we move the 16 to the left, since the 16 is positive, we're going to move it and it will be negative. 9 x squared. Negative 16 x squared, when we move it here. We're going to have a subtraction there. And the solution will be negative. So if we do that, if we move all of these terms to the left, we're going to have to work with a negative number. I don't like that. Why don't we move the things in the right, the things in the left to the right? By doing that, that subtraction will have to be positive. And now we're going to be working with positive numbers instead of negative. Okay, let's do that then. So I am going to move everything in the left to the right. If I do so, I am going to have a 0 right here. 0 equals a lot of things, right? The first thing is the 16x squared, 16x squared. And just so that we are organized, I am going to write immediately this term, negative 9x squared. Did you see what I did? I just wrote the 16x squared that I had to the right, and also the negative 9x, negative because I moved it to the other side. And I did that so that we can see the subtraction of like terms. Remember, this x squared and this x squared makes it so that these two terms are like terms, and they can be subtracted, right? Let's continue. Also, we have another x squared here, so why don't I just write it immediately after x squared? That concludes all the x squares. Let me write the squares here. That concludes this, this, and this. All right. Let's continue with the x's. And we have 78x and 40x. So let's write those. Plus 40x, the one that is positive, and then the one that should be negative, because again, it was positive, 78x is positive, but I am moving it to the other side of the equation. So minus 78x. That concludes the x's. Now, the constant values, 25 and 169. Okay, we're going to have our 25 here, 25, positive 25, and the negative 169. Again, why negative? Because it is positive in this side, but when we move it to the other side of the equation, will be negative 169. There we go. And now all we have to do is do the operations that we can. Do the operations that we can. Unfortunately, I don't have enough space down, so I'm going to have to write the rest of the solution on top of the board, or in the part, in this part of the board. Let me just write something like this. There we go. There. Okay. So let's try to do these operations. I want in the chat, please, if you know the answer, go ahead and write it down. How much will be this whole operation simplified? 16x squared minus 9x squared minus x. Then 40x minus 78x. Then 25 minus 169. If you want to use a calculator, you can. Go ahead and write it in the chat, please. Okay, we have two answers now. Let's take a look. People are saying correct, and then correct, and correct. Mahofo negra. Just like the first time, you are a winner. You won, my dear. You won. Congratulations. But we also have an answer from Juli Parra and Ethan, as well as Richie and Lau Anzola. Congratulations. Actually, to be precise, only Richie and Lau Anzola have the correct expression, because these two people did not forget about the 0 and the equal. These people did not forget about the 0 and the equal. But you guys did it right. I just asked about this part. So all of you guys, you are correct. The solution will be 16 minus 9 minus 1. This thing is 10, 16. So that means, let me write the 0. 0 equals, this thing will be 6x squared. Beautiful. From here, let's work on the x's. We have 40 minus 78. Well, this thing will be negative 38x. All right. What now? Well, now the constant values, 25 minus 169. Okay. This will be negative 144. And now we have our quadratic equation equal to 0. And we can apply the quadratic formula to that equation. If we do that, if we apply our quadratic formula, we're going to know the values of x. And that is exactly the question of the exercise. Look, the question says, what are the dimensions of the triangles? In other words, we need to find the value of x and then replace here to know the value of the hypotenuse. Replace here to know the value of this leg, and then replace here to know the value of the leg that we're missing. Huh? Look at that. Our idea of applying the Pythagoras theorem worked. Of course, we haven't finished the exercise, but it worked. This is beautiful. This is beautiful. We are mixing algebra with geometry. This is beautiful. All right, let's continue. Man, I'm excited now. All right, let's continue. We need to solve our quadratic equation, right? So, there we go. Did you guys remember what is the quadratic formula? Did you guys remember or not? In the chat, please. Can you guys remember the quadratic formula? Okay, I have 2 people saying yes. Beautiful. 3 people. Okay. Congratulations. Only 3 people though? Sara is also saying yes. Lawansola, Daniel remembers it. Maria Emma remembers it. Okay, 7 people then. 8 people. Juliana. Cool, Juli. All right. We have 8 people who remember the formula and the rest who don't. So I'm just going to write the formula real quick. The quadratic formula is x will be the value of, we have a fractionary, and on top we're going to have negative b plus or minus the square root of b squared minus 4 times a times c, the values of a and c, and the denominator will be 2 times a. All right? But we need to know first, what are the values of a, b, and c? We need to know those values first, right? So let me write them right here. The value of a, the value of b, and the value of c. What will be the values of a, b, and c? Okay, the value of a is the coefficient of x squared. X squared, there we go. X squared is over here. The coefficient is the little number that comes with it. So 6. There we go. B, all right, let's take a look at B. B is the coefficient of the x. So we have our x in here. The coefficient will be negative 38. Negative 38. And last but not least, C will be our constant value, which is 164. Actually, negative 144. 64. I meant to say 44, sorry. So now we have our values of A, B, and C. If we replace in the quadratic formula, we are going to have our solution. Right, x will be then negative b, but b is negative 38. So we'll have positive 38 now, right? The negative of the formula and the negative of the value b get canceled. So we have positive 38 plus or minus the square root of b squared, which is 38 squared, right? Negative 38 squared, right? Let's continue. Minus 4 times the value of a, which is 6, and then the value of c, which is negative 144. There we go. And all of this over 2 times our value a. 2 times 6, we can do that immediately. This is 12. 2 times 6. Okay, and what now? We have a huge number here. 38 square. I'm sorry, negative 38 square. This thing is huge. And also this, negative 4 times 6 times 144. Man, that thing is huge. You're going to have to use a calculator for this one. In the chat, please. If you know the solution of the thing inside the root, inside, don't find the root yet. Please, just do the discriminant, only the thing inside the root, and tell me the solution, please. Use a calculator for this one. All right, let's see. Jose Ricardo says negative 8 over 3. No, but just the thing inside the root, Richie. Tefa says 4,900. Richie says negative 2.7. No, but just the thing inside the root without finding the root, okay? Maria Paz says 4,900. So 4,900. Okay. Ethan says the same. So we have 3 people who are saying the same. Luna is saying the same. Okay, 4 people now. All right, I'm going to trust you guys. Trust you. So 38 plus or minus the square root of 4,900 over 12. All right. Okay, cool. Can we find the root of 4,900? Yes, we can, right? We can find the root. This will be 70, right? Well, look at that. A lot of people are writing in the chat. All right, congratulations. Ethan, Tefa Cabrera, Lau Anzola, and Luna Campo just said 70. Congratulations. So this will be, let me write it here. X will be equal to 38 plus and minus 70 over 12. And now we can expand. We can divide, split our operation. Remember, one operation will have to go with the positive sign, plus, and then the other one will have to go with the negative sign, minus. All right? So let's see. Man, this exercise is long, right? All right, let's go. The first answer will be x equals 38 plus 70 over 12. Do you know the answer of this? Please, in the chat, everybody. This will be 108 over 12. Do we have a decimal for this? No? Can this be simplified? I can do 6, I can do half, and then 3. Yes. Okay, oh, wow. This thing is completed, right? This thing is 9. 2 carry. This thing is 9. Let's see the chat. Okay, people are saying that x equals 9. Congratulations. Beautiful. That is with the positive sign. Let's go now with the negative. We have 38 minus 70 over 12. Now, how much will this be? This will be negative 22 over 12. 32. 32 over 12, right? And if we simplify this, we can find this thing is not a number alone. This thing has a decimal. We can leave it as a fraction though. This will be 8 over 3. 8 over 3 are saying, man, you guys are faster than me. Congratulations. Negative 8 over 3. All right. Negative 8 over 3. All right, pretty good. Then, of course, we can approximate this to a decimal, right? This will be the third part of 8. 2.3, 2.333333333, right? No? No, 2.666666666, right? Okay, we can say 2.7. Let's leave it as a fraction, and then we will see what we can do, all right? As of now, let's leave it as a fraction. All right, but we have two solutions. We have 9, and we have negative 8/3. So let's go back to our exercise and answer the question. The first question says, how many triangles have these measurements? Okay, we have two answers. So how many triangles can we do? In the chat, please, guys. How many triangles can we do? We have our first winner. Nobody else? Marino just said 1. 1 triangle with these solutions. You can see the answer. Sorry, you can't. Let me change these real quick. There we go. A lot better. A lot better. There we go. Better. Sorry, guys. You couldn't see the solutions. There. 9 and negative 8/3. Okay, so now a lot of people are saying 1 triangle. Okay, but why 1? We have 2 values. I mean, if we replace 9 in here and in here and in here, we're going to have one triangle with those measurements. And if we replace negative 8 over 3 here, here, and here, we're going to have our second triangle. So why this one doesn't count? And Marino, again, with the answer. Porque no puede ser negativo. Yes, sir. This value has a negative. And in geometry, in real life, we don't find measurements that are negative. Look at this. This value x alone will be negative 8/3. So this leg will be a negative value. How is that? How that works? Is the leg inverted? that doesn't work. Same here. If we replace it, sure, we were going to have to multiply negative 8/3 by 3 and then add 13. We're going to have to do things. But the result will be negative. Also here, probably negative. Probably. Also probably. I don't know. But it is negative for sure here. So this value does not count. We do not look at negative 8/3. We only look at 9. This happens in mathematics all the time. Whenever you guys are working equations that are like these, quadratic equations in examples, the solutions, you guys have to analyze it even further and see which one of the solutions works in the example. Sometimes both solutions work. Sometimes no solution at all work. And in that case, we write, this exercise has no solutions. But in this case, only one of the solutions work, the number 9. So we know how many right triangles have these measurements? Only one. Only one triangle have those measurements. Only one triangle. And now the question is, what are the dimensions of that triangle? Okay, so we need to find the dimension of the hypotenuse, the measurement of the hypotenuse, sorry, the measure of this leg, and the measure of this other leg. What that means is replace the x by 9. All right, here we go. So if we replace the values, this leg will be 9. Remember, this one was x alone. So now we know this leg is 9. Let's go with this one. Replace the x by 9. So let me erase the x and put a 9 in a parenthesis here. Meaning this leg is 3 times 9 plus 13. How much is that, guys? All right, this will be 27 plus 13, which will be 40. You guys are too fast. You guys are doing this even faster than me. Lau Anzola and Tefa Cabrera, congratulations. You guys are doing this even faster than I am. So 40 will be our last leg. And now for the hypotenuse. Replace the x by a 9. Let's see. And now let's see if I can do this faster than you. 4 times 9 plus 5. This will be 49, 45 plus 5, which will be 50. Ha! I won. Ha ha! 50. Am I doing it correct or not? No, I'm not doing this correct. This will be 36 plus 5 will be 49. Let's see. Nah, you guys finished in time, man. You guys beat me as well. All right, pretty good, guys. Yes, 36 plus 5, 41. So let's look at the answers. We know one triangle was the only possible solution to this exercise. And the dimensions are this leg, 40 inches, this leg, 9 inches, and this hypotenuse, 41 inches. Congratulations, guys. And this was all because of you. Pretty good, huh? All right, guys. I'm going to finish the video right here. And we will finish the class in a minute.